Hello, students. Very good afternoon, good evening, good morning, whenever you are watching this lecture. Now, up to the last class, we have seen hydrocarbon part 5, and up to that, I have completed you the rearrangement of carbocation and dehydration of alcohol, that is, follow E1 mechanism. Now, we are going to proceed the part number 6, and again, I am suggesting you all. Those who have not watched part 1 to part 3, part 4, part 5, part like that, don't see part 6. Don't increase my view of the lecture. Just see line by line. Trust me, if you will complete each and every part of organic chemistry, what I am teaching, not a single question will be going to be left from advance also. But practice needed. And after that, we will do lots of questions. Now, next part of the topic in part 6 is known as bimolecular elimination reaction. Bimolecular elimination reaction. Now bimolecular elimination reaction is also denoted as E2. It means we are going to see E2 mechanism. What we are going to see? E2, very important, and trust me, I will dictate you in such a way that totally new you will get. E2 means bimolecular elimination reaction. Now, first of all, we have to know what is the reagent can be used in this reaction. The first reagent used. The reagent used over here is base. Base is used. Which type of base? I will show you. Don't worry. Either example. Suppose they have written like this. MEO minus, some place directly minus written, RO minus or PHO minus, like that. Some place there is a minus on oxygen, or they will write alcoholic KOH. Alcoholic means C2H5OH ethanol plus KOH, or they will write alcoholic NaOH, like that written, or some place written sodium. These are all reagent. Sodium alkoxide. Sodium alkoxide. Sodium alkoxide, like that. If they will write MEONA, sodium methoxide, or they will write MEO minus also, both have the same meaning. Sodium alkoxide, sodium methoxide, sodium ethoxide, like MEOK, potassium ethoxide, or MEO minus, because salt is always present in the charge, minus plus, so K plus will remove and MEO minus, like that written. Or some place they will write NaNH2, or some place they will write NH2 minus, or some place they will write like this, kabhi ONA. This can be also written as tertiary butyl BuONA or TBuOK. Like that they will write reagent, means these are the reagent used. This is tertiary group, na, to T I have written, and Bu means butyl, 1 2 3 4 carbon, to butyl, O K or Na, like that. These are the reagent can be used in these cases. What happens after using this reagent? And trust me, totally new I will dictate over here. Have you never seen this part like this before? What happens? Suppose I will take kabhi. Now over here I have taken some base as a minus and heat. What will happen? This will go, and over here just nearby that it is beta. Over here no rearrangement. In this part previously we are doing alcoholic dehydration of alcohol, we are doing rearrangement, ring expansion, because they will follow E1 mechanism. Over here no rearrangement. Only one thing, over here no rearrangement. It will also known as beta H plus elimination, like that. Beta H plus elimination, it is also known for E1 mechanism, and this is also known as beta H plus elimination. You will those who have watched it already, they know that from here or from here you will remove hydrogen, so one alkene will coming like this and one alkene will come like this. These two product will come. Understood? Now question arises कि sir we got with two product, which one is major and which one is minor. So previously what you are saying कि sir more number of alpha hydrogen, 6 alpha hydrogen, 2 alpha hydrogen, so this will be minor and this will be major. Now in this part you can't say like that. I will dictate you the trick how to find major and minor. Don't say with more number of alpha hydrogen. There is some different rules. What is that rule? I will tell you. Now for this, before going to know how to judge major or minor, first of all I will dictate you some this is the most important point. First important point coming ki how we are going to judge which one is minor and which one is minor. First question arises this. I will clear that question. Second part of the important thing is that one important points regarding E2 mechanism. One important point regarding E2 mechanism is that ki suppose I have given over here, I will write the point that elimination is done is anti-elimination. Which elimination? Anti-elimination. What do you mean by that? We didn't understood. Again, understood. This is the reagent. If you will take reagent, two types of product you will get at 1 degree and at 2 degree. First question I have arises that which one is the major product, that I will dictate later. But before that, some important point, elimination is done, but that elimination is anti-elimination. Means suppose I have taken one example. In that example, over here I have taken Cl on the base dash and CS3 on the base, and over here also I have taken one CS3 on the base. Now I will say ki react this with some base negative. I am reacting this. Now you will remove this Cl from here. Now this will be beta, this will be beta. Now check, you have to remove what? Hydrogen from here. Hydrogen is also on the dash, and here hydrogen is also on the dash because CS3 already present on the base. So once you are removing the Cl from dash, so another part you have to remove hydrogen from base, but both hydrogen is present on the dash, so no reaction, no alkene will form. Means sir, suppose some other example, sir. Suppose I will say this example. Over here Cl is here, and over here CS3 like this, and over here CS3 like this. I will take lots of example, don't worry. CS3 like this. Now you will remove this Cl. According to this beta, this beta. Here hydrogen is on the dash, so this hydrogen will not remove because Cl has been removed from dash. But over here CS3 on the base, on the dash, so hydrogen will be on the base, so this hydrogen will go. Yani if I will take base minus, only one side double bond will come. This CS3 will be as it is, this CS3 will be as it is, and double bond will come here because this hydrogen you are able to remove, this hydrogen you can't remove, so double bond will not come here. Understood the point? Suppose I will take another example. Sir, acha, base dash not given, sir. Something given like this. Ki over here we will have Cl, and over here we have CS3, and over here we have CS3. If base dash not given, then you didn't have to worry. Remove this Cl, and this is beta, this is beta. Base dash not given, then you will directly do ki over here CS3, over here CS3, one possibility double bond here, and another possibility CS3, over here CS3, over here one double bond. You didn't have to worry about ki which one is base, which one is dash, because base dash not mentioned. Not mentioned, then do normally. Then no checking of anti or syn addition. Over here anti-elimination, no need to check. But base dash especially mentioned. Suppose I will take another example over here, and here I have given this CS3, and over there I have given Cl. And then I am doing with base minus. Over here nothing given. What you will say? Ki sir, this Cl will go, this hydrogen will go? No. Why? Because this hydrogen is on the dash. Over here nothing is given. So consider कि this hydrogen will go. It means one hydrogen over here is on the base, one hydrogen is over here on the dash. This hydrogen you will remove, and you will get the product over here CS3. Cl will go, double bond coming here. If not mentioned, then remove it. If especially mentioned, then check. If Cl is going from dash, then the hydrogen will go from base. If Cl is going from base, the hydrogen will go from dash. So I hope up to this you have understood what I am trying to dictate. Now this point I am going to justify how we will judge which one is the major one and which one is the minor one. Now major, minor. Acha, sir, write this point what you have said about anti-elimination, that when Cl or any living group, Cl, Br, OH, any living group is dash position position, then hydrogen base position, then only happen, and vice versa, if base dash not mentioned, then no problem, just do elimination, without seeing it, because they have not mentioned base and dash. If it is mentioned, then only we will check the anti-elimination. Now the next part of the topic, how to judge, what is the major product or what is the minor product, how we will judge it, which one is major and which one is minor. So before judging it, you have to know one chart I am going to draw, flow chart, and with that flow chart you are able to judge which one is major, and I will give example also, don't worry. It flow chart is that कि some place, this visible sir? हाँ sir, visible. Some place they will give you base. And now this base will be moderate base. What are the moderate base? Moderate base are like alcoholic KOH, like alcoholic NaOH, or like RONA, or this base will be a strong base. What are the strong base? Like this bulky group type ONA or NaNH2. These two design ONA, or over here OKA, or tertiary butyl sodium alkoxide or potassium alkoxide, like that written, they are strong bases and they are weak moderate bases. Now if moderate base is there, so it has two things, either very good living group or that moderate base plus poor living group. How we will know that, sir, which one is very good living group, which one is poor living group? So I am going to write poor living group. Poor living group are fluorine, OH, OR, Nr3 plus and Sr2 plus. If this group will be there, then you will say that these are poor living group. Rather than that, anything coming, that is good living group. So 4 to 5 F, OH, OR, Nr2, Sr2. We will learn remaining everyone is very good living group. Now if moderate base given, not a bulky base, and over here two situations, either very good living group. What are very good living group? We didn't know, sir, but poor living group we know that. If it is not there, then very good living group. Now over here, if very good living group coming, then except this, then in this situation the major product will be the major alkene. Means which has more number of alpha hydrogen, means more number of alpha hydrogen, that will be the major product. But if poor living group coming, or strong base coming, if poor living group coming as well as strong base coming, in this situation the major product will be decided by most stable. I will write that again. Understood? I have written one flow chart. In that flow chart I have told you how to judge major product and minor product. First of all, you have to check base. The base is moderate base like alcoholic KOH, alcoholic NaOH, means not like this. Strong base are fixed. This or this. This I have only designed like this, na KB, tertiary butyl. If this is not there, then moderate base. In moderate base, check ki the attached over here group is not fluorine or not OH or not OR, like that. If these groups are not there, then it will be very good living group. If it is very good living group, then major alkene will be the major product will be the major alkene which has more number of alpha hydrogen, that will be the major product. But if F, OH, OR, Nr2, Sr2 or a strong base coming, in a strong base we didn't have to check poor living group. If any situation, either poor living group or this will come, then means this moderate base plus poor living group or direct strong base, if it is coming, then in this situation we will say ki the major product will decided by negative, means we are I will tell you what is negative, means most stable negative after removing H plus. What do you mean by that? We didn't understood it. Just wait. I will write example and you are able to understood it. Suppose I will take one example. Just see it. This flow chart is very important. Over here Cl and over here I have taken alcoholic KOH. Check. Alcoholic KOH is a moderate base and Cl is not a poor living group. Then you will remove this Cl. This will become beta. This will become beta. Kabhi 1 and kabhi 2. This has 6 alpha hydrogen, this has 2 alpha hydrogen, this is simple major, this is simple minor. Any problem? No sir. Acha. Next example. Suppose next example I have taken this ORA PA Cl. In place of alcoholic KOH I have taken this ONA. Now again you will remove this Cl. After removing this Cl, here is the beta, here is the beta. What you are doing? From beta position you are removing hydrogen removing, na minus coming. Over here how it will happen? Beta position hydrogen is there, they will remove, minus will come. This minus is only forming double bond, na? Then only double bond here coming, na? Here minus will form after removing, double bond coming, then only double bond coming here, na? So here you will get negative, here beta position you have to put negative, simple logic. Now check which negative is more stable, sir. Means before getting the product, after removing Cl you will get negative here, you will get negative here. We know that negative charge over here plus I from both side, over here plus I from only one side. So this negative is most stable. It means you will get two product like this again, this and this, but this negative is most stable. So this will become major product and this will become minor product. Means on the beta position you have to put negative and check which negative is more stable. I mean, you know that negative is not good for hyperconjugation. So now this time coming major, this time coming minor. But in this situation someone will ask what is the Sedgwick product? So major product is Sedgwick. If then anybody is asked what is the Hoffman product? Minor product is Hoffman. But major or minor product is not Hoffman or Sedgwick. Major alkene, either this is minor product but still it is Sedgwick product. Because over here minor product but alkene is most stable. Alkene most stable. Matlab which one is coming in more quantity? That is major, and which one coming in less quantity, but after having bulky group, most stable alkene coming less quantity, but less stable alkene coming more quantity. So more stable alkene is always Sedgwick and less stable alkene is always Hoffman. Means Hoffman and Sedgwick is not decided by major or minor, it will be decided by most stable alkene. Now understood what I am trying to say? Sir, now something coming, means whenever bulky group is there, after putting minus you have to check which one is the most stable minus. Their alkene will be the major product and least stable minus is minor product. But whenever normal moderate group without poor living group or bulky group, then more alpha hydrogen you have to check. Not understood, sir. Some more example. Okay, don't worry. Suppose I have taken one example, kabhi OH over here, and then I have taken alcoholic KOH. Sir, alcoholic KOH plus poor living group, OH is there. Acha. So in this part first you will remove this. In this part first you will remove this. Here beta, here minus coming, here minus coming. Which minus is more stable? This minus. So one product you will get alkene here, one product you will get alkene here. This is the minor product, this is the major product, major alkene. Major product means major, more quantity coming. But if then you are asking which is the Sedgwick product, the most stable is this one. Alkene is stable over here, it is least stable, but least stable is coming in more product. What I will do? More number coming, I can't do anything. Means still it is the Sedgwick product or Sedgwick product, and still it is the Hoffman product without any doubt. But if they will ask what is the major product in this case, you will write this. Understood? Means suppose I will take one more example, kabhi Cl, and I am reacting with AgF in presence of RO minus. What you will say? First reagent is AgF, second reagent is ROF. AgF is Schwarz reaction. Schwarz reaction, and Schwarz reaction will do halogen exchange method, and once it will do halogen exchange method, what you will get, first Cl will remove and F will come. Then second reagent is RO minus. Acha sir, poor living group and alcoholic moderate base, minus here, minus here. So which minus is more stable? This minus. So this is the major alkene, major product. This is the minor product. This is the major product. This is the minor product. But most stable is this one. Least stable is this one. So most stable is Sedgwick and least stable is Hofmann. Yani major minor can be decided by different way, but Sedgwick and Hofmann can be decided by only with the most stable alkene. Understood this part? Lots of example I will take, but I am going to write one more example, that Sedgwick or Sedgwick product, Sedgwick or Sedgwick product. Understood this part? Not understanding, again message me. These won't be affected either major or minor product. This will always most stable alkene. Either most stable alkene is produced in a minor quantity, no problem. Same for Hofmann. It is always least stable alkene. Now problem is that least stable alkene coming, major product more quantity coming, that is not the problem. But Hofmann and Sedgwick will be decided like this. Now suppose I will take some more example. I have taken one example like this, and over here I will take this bulky group, or I will take this I have taken. What you will say over here, suppose Cl, bulky group minus minus. This minus is more stable. So over here we will get the ringa chinga pinga, one double bond, and ringa chinga pinga. This is the major product. This is the minor product. But still it is Hofmann. Either major is there Hofmann, but because least stable, and it is Sedgwick. Understood? So I hope you all are able to understood what I am trying to dictate, but still I will take from my convenience some more example. Suppose I have taken one example over here, and here H, here CS3, here H, here dash, suppose dash Cl, and I am giving ETO minus. Acha sir, over here moderate base plus not a poor living group, it will go. Now over here you will get negative here and you will get negative here, because over here base dash not given. So you will draw two structure. One structure will be CS3 here, because anti na, so base and dash anti coming na. So over here one double bond here, and another possibility one double bond here. Ab now check which one has more alpha hydrogen, that is the major product, and which has less alpha hydrogen, that is the minor product. It has 3 to 5 to 7 alpha hydrogen. It has 1 and 2, 3 alpha hydrogen. Over here, because it is, we are not going to judge according to the basis of negative charge, so we will say it is the major product and it is the minor product. This time major product is also Sedgwick and minor product is also Hofmann, because minor product is least stable alkene and major product is most stable alkene. So I am not judging the Hofmann and Sedgwick according to major and minor. I am judging according to most stable alkene and least stable alkene. Understanding. Haan sir, we are understanding it. Suppose I will take some more example. Writing I will write, and we will see what is going to be happen over here. Some more question I have written over here. See, now anti-elimination. This Cl will go. Acha sir. This is dash. This is also dash. Over here nothing written. No waste dash. You can remove this H. From here what you will get? Upside not be touched, because this is not coming anti-elimination. Over here double bond will come. Understood na? Where not written anything, no need to check. Acha. Over here hydrogen is on H dash dash. From dash Cl is going. No reaction. Because hydrogen has to remove from anti. Cl is also going from dash, and both side hydrogen not present. But CS3 on base means hydrogen is remaining other place, that is dash. Over here if only alcoholic KOH given, so any one Cl will go, and it will become CH3. It will become CH2 double bond CH2 Cl. Only this. But hydrogen is more, to remove it. CH Cl. 1, 2, 3, 4. Only one Cl. But alcoholic KOH plus high temperature given, both Cl you will remove, and you will get CH triple bond CH. If alcoholic KOH given, one will remove one Cl, one will remove one Cl, CH2 double bond CH and Cl, and this will remove another Cl. So overall you will get CH triple bond CH. But same NaNH2 given over here with Cl, but over here alkyne, so it will do acid base reaction. Why? Na plus, so one hydrogen will go from here, it will become minus, Na will attack, it will become Sc triple bond C and A. Then CH3I, it will break as minus plus, it is already plus minus, then this will come here Sc triple bond C CH3. So NaNH2 has two parts. Either it will do acid base reaction or it will remove Cl. If it is only one Cl is there, then it will do elimination type. If Cl is not there, some alkyne group is there, then it will do acid base reaction. Na will come, salt will form. Then CH3I will break like this, minus plus. Plus will attack over here because it is already minus. So plus will attack here, minus will attack here. So outside you will get NaI, but byproduct is not that much important. This is all about E2 by molecular elimination reaction. Now I am going to see E1CB, then electrophilic aromatic substitution. Like that I will tell you, and slowly more one part after that. I will hope that this chapter will be completed. Very important chapter and very big. Those who will understood this chapter very properly, for them very interesting part. Now E1CB, E2 mechanism done. Everyone will see it very properly. Not getting, again see, if you have watched up to that, then you will take my number 9267937718. Those who have seen up to that, for them WhatsApp number. Any doubt you can ask, please ask. I have already told lots of time that I am not here to become superstar. I am just here to teach to known students. Some places I have already taught, but there I am not right now. So a student is not able to get me, and they are getting confused. Sir, new teacher is not teaching good, like that. So I just want, and those who I am teaching, for them revision will be there. So please ask any doubt. Now, sir, okay sir, we understood every video you are saying that. I know that every video I am saying, but I didn't know which video you are watching. If you are watching every, for you it is a boring, but not watching, it is a new for you. Okay sir, understood. Don't do bakwas. Now teach. Okay. Now E1CB is unimolecular conjugate base. Unimolecular conjugate base elimination reaction. Elimination reaction means, sir, E means elimination, 1 means unimolecular, CB means conjugate base. First important point, he used while aldol condensation. Sir, what is aldol condensation? When I will teach you aldehyde, ketone and carboxylic acid, over there I will dictate you what do you mean by aldol condensation, and over there we are using this mechanism. Second important point, it will happen in the presence of poor living group. Acha, what are the poor living group I have written? Sir, fluorine, OH, OR, NR3 plus, SR2 plus. These are the poor living group. It will happen in the presence of poor living group, SR2 plus, as well as, and electron withdrawing group. Electron withdrawing group means minus I effect. What do you mean by that? Sir, give some example. Suppose I will take kabhi over here double bond O. This over here OH, over here this. Now you will take alcoholic KOH. Reagent is same as E2. Now you will say, sir, alcoholic KOH, either it will do E2 or it will do E1CB. OH will go, this will become beta, this will become beta, and this is electron withdrawing group. Okay, so it will not do E1C, E2, it will do E1CB. 1 minus will come here, 1 minus will come here. This minus is normal, but this minus is stable by minus I effect. C double bond O will show minus I effect. I have already dictated. So this minus is more stable. So what you will say, sir, two product is coming. One product, double bond O, here, 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 and double bond will be this place on this beta. So double bond will coming here because of the most stable negative charge. Another product we can form, yes, but that is the minor product. Over here you will get double bond, but this is very minor. In E1CB only you have to form major. If you want to form minor, you can form it also. Understood? And not major, it has 3 alpha hydrogen, it has 2 alpha hydrogen, it has 3 alpha hydrogen, 2 alpha hydrogen, more stable, ZGIF and ZSIF will be same, and it is Hoffman. Over there, no confusion. But this time, E1CB. Understood? This is simple. But, when there is no poor living group, then no E1CB. Suppose electron withdrawing group is there, but poor living group is not there, still no E1CB. Understood? So this is all about E1CB mechanism. More example, no need to check because very less type of question coming. Only one place it is going to be used, that is aldol condensation. Now, after this, everyone I have already dictated, but still I am going to dictate. I have dictated you Finkel-Stein reaction. I have told you that Finkel-Stein reaction is also known as halogen exchange method. Halogen exchange method. What I will do in that? First I am taking some Rx, X will be Cl or Br. We are forming it by using free radical mechanism. Then I will take NaI in presence of acetone. This is acetone. Or you will say NaI in presence of dry ether. Anything you will take, what will happen? Ri will form and NaX will form. Any problem is that? Yes. Now, on this same basis, why I have dictated it, this will come in alkyl aryl also, detail I will do there. But what I have dictated is, like this same, one more reaction is there, that is known as dehalogenation reaction. Simple like Finkel-Stein reaction, dehalogenation reaction. Now, what is dehalogenation reaction? And on this basis, on Saturday exam, those who know that, to whom I am talking about, on Saturday there is a test. On that test, question is also coming. Suppose I will give like that. Acha, one more thing you will write about dehalogenation. Like that I have told you, na, whenever you are doing the E2 mechanism over there, anti-elimination, it is also anti-elimination, not sin. Anti place you have to remove, means suppose sin anti not given, no problem. Suppose Cl is there. Suppose you will take NaI in presence of acetone, or you can take Zn and heat. Anything you will take. What will happen? This both first, understood. Not or, don't take. Suppose you have taken NaI plus heat. What will happen? NaI plus heat will convert that into I and I. Then Zn and heat will take both the I and making double bond. So first it will do, sorry, by mistake I have written one, correct. Both double bond and over here means first it will do Finkel-Stein. After doing Finkel-Stein, it will remove both the I. No need to do Finkel-Stein. Directly you can remove it. If Z and I given heat or not, or you can, means suppose I will give C, over here Cl, over here CS3, over here Cl, over here CS3. What you will do? You will remove this two. Anything given, either given NaI plus acetone, double bond, or given Zn plus heat. Sir, what is the difference between the bottom one and top one? Sir, top one, only one X is there. Over here, 2X is there. So you will remove all the two. What you will get? C, double bond C, CS3, remaining place, hydrogen you will put. What is the required hydrogen? Don't see. Acha, suppose someone will give C, Br, and H is there. Now, they will give NaI in presence of acetone or Zn in presence of heat. What you will do? All Br you will remove. 2 Br is giving one bond. Another 2R Br will give another bond. So what you will get? CH triple bond CH. Means only one halogen is there. Then it will do, you will do halogen exchange method, means I will come and Cl will go. But more than one halogen is there. Both halogen will go. If 2 going, 1 double bond, 4 going, 1 triple bond, like that it will come. Acha sir, you have written anti-elimination. What do you mean by that? Suppose I will take one example over here. What is that example? Kabhi, kabhi, kabhi. Over here 1 Cl, over here 1 Cl. Suppose I have taken like this. Over here 1 Cl. Like that I have taken. And I am taking NaI in presence of I, in presence of acetone, or Zn in presence of heat. Thus it will form double bond? No sir. Cl over here. That it will form double bond? No. It will do only halogen exchange method. I will come and over here I will come. After that double bond will not form because anti both are present on the Veg position. One will be Veg, one will be dash. Suppose I will take this example. Over here Cl and over here suppose Br in presence of NaI and acetone or Zn plus heat. First I will come, over here also I, and over here also I. Now these two I will go outside and it is forming double bond because one is Veg, one is dash, one is Veg, one is dash. Understood the point? Suppose I will take one more example. If Veg dash not given, then no need to check. Simple you will do. Previous example I have done like that only. Suppose over here Cl, 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 and I am giving NaI in presence of acetone or Zn and heat. What you will say? This Cl and this Cl will go one double bond. This Cl will go one double bond. This Cl and this Cl will go one double bond, and you will get a aromatic compound, that is benzene ring. If Veg and dash not given, no need to see anti-elimination. If Veg dash is given, then you will see anti-elimination, and this is all about elimination reaction. After that I will teach you electrophilic addition reaction. Electrophilic addition reaction. If it will take more 2 part, no problem, but I will try to complete it slowly, so you will not get nervous and confused. Too much big video I don't want to give. Okay, so bye. Have a nice afternoon, have a nice evening, have a nice morning whenever you are watching this lecture, and I hope you are understanding. Not understanding, as usual you can ask the question on the WhatsApp number. Bye.